Okay, I think we can get started. So thanks everyone for being here. I'm pleased to welcome you to the 30th Annual Frank M. Coffin Lecture on Law and Public Service. Thank you for joining us this evening. Even though this is the 30th anniversary of the lecture itself, we haven't been able to get together in person for 3 years now, since 2019, when Richard Mayewski was the speaker. It's nice to be back in person and see your faces. I'm Dimitri Baum. I'm the Vice Dean, Provost, and a Professor of Law at the University of Maine School of Law. I was planning to be in the audience with you today, but I'm pinch hitting for Dean Lee Softly, who unfortunately couldn't be here due to a death in the family. The Coffin Lecture is one of the Maine Law's signature events. Other schools might have more of these kinds of events. We're small and scrappy, as one of my colleagues says. So we like to be selective. Right? But the ones that we do put on, we are very proud of, and we're really proud to sponsor the annual Coffin Lecture named after Judge Frank M. Coffin. Unfortunately, I never had the opportunity to meet Judge Coffin before coming to Maine Law. I had heard of him. I knew him by reputation. My scholarship is in the field of judicial decision-making and judicial ethics, and Judge Coffin is one of the leaders in that field. He had written prolifically about judges and judicial decision-making, written 2 books about the role of a judge in the system and judicial decision-making process. Only after arriving at Maine Law did I really learn about his remarkable legacy beyond that work as a judge, and his wisdom, his intelligence, his commitment to social justice and public service. And so it's really fitting that today's talk will be about perhaps the most important existential issue facing us today. Judge Coffin really cared about the craft of judging, and in particular, the legitimacy of the courts, of the judiciary. And I think today, as more and more people are questioning that legitimacy, I think Judge Coffin's legacy is perhaps more important than ever. I have a shelf of biographies, judicial biographies in my office. They're alphabetized, and I'm excited and honored to have Judge Coffin's biography right there next to Justice Cardozo, who's right before him alphabetically. So thank you to Richard Mayewski, and the books are available out in the lobby as well. There are a few distinguished guests here tonight. I'm going to go with a better safe than sorry approach and not start naming the special guests. I do want to extend a special welcome to the Coffin family. 2 years ago, while I was keeping the deanship warm for Justice Softly, before her arrival, I was fortunate enough to spend some time with the Coffin children, and it was really a pleasure to get to know you better and get to know the judge better. And also welcome to the Coffin clerks, the community of the Coffin clerks. The Coffin Clever, as they're known. It's an impressive group of over 90 really diverse lawyers, judges, professors, civic leaders. They helped establish the series 3 decades ago now, and they've sustained a tradition in the spirit of this celebration of Judge Coffin's values and legacy. You can tell how important this event is to us by the number of speakers and introducers that are going to take the stage before the main event. All right, sometimes there's 1 or 2. Today there's going to be 3. As the MC, my job is to keep this moving along in a timely manner. So rather than take up too much more of your time, I want to introduce the Chancellor of the University of Maine System, Daniel Malloy. He began his job as the Chancellor on the same day as I began my brief stint as the interim Dean. And I'll tell you that Maine Law could not have had a better ally, could not have a better ally in the Chancellor's office. I think many people in this room are aware of the challenges that Maine Law faced when he arrived. And while all of higher education continues to face some of these challenges, the law school has not been as respected in as strong a position as it is today within the University of Maine system and within the state. There are a lot of people that contributed to that transformation, including the Board of Trustees, but I know everyone in the kind of hideous round building across the street is aware that we would not be where we are today without Chancellor Malloy moving to a beautiful new space as well. And the Chancellor, like Judge Coffin, devoted his life to public service. He served for, I think, 14 years as the mayor of Stamford, Connecticut, then 8 years as the governor of the state. He also has a JD degree, which he earned from Boston College Law School. Dean Softly and the Chancellor have this amazing report and kind of an amusing repartee that I can't replicate, unfortunately. I wasn't lured here under false pretenses. So I will just ask you to join me in welcoming Chancellor Malloy to the stage.
Thank you. It's a great honor to be with those of you in the room and those following electronically. I was able to attend the 2019 really outstanding presentation of the Coffin Lecture, and very much enjoyed it. And although there have been other replacements online, it's good to be back in person and have an audience, and I think it probably is that much more interesting for the lecturer to actually be able to sense the room. Just a couple of quick things. Number one, I believe the judge was way ahead of his time. I attended law school beginning in 1977 and read a number of things by statements by the judge, including decisions, and was honored to get to know him through the law. Someone who was way ahead of his time in understanding the interdependence of the legal community with the business community, with the lives of human beings on a regular basis, and how we were impacting, or how we as lawyers were impacting that relationship. And we go from that to understanding and, quite frankly, addressing, or at least facing, the great challenges to our environment, and to some extent understanding how quick the degradation takes place and how uncertain the response to that is. I think the best way to be addressing an issue like that is to do it in cooperation with fields of study across a broad spectrum, to understand the economic consequences, the agricultural consequences, the lifestyle consequences, the weather consequences, all of which are addressed. What we're trying to do as a university system is to make sure that everyone understands that interdependence and is ready, willing, and able to work across borders that were firmly protected at one time, but now understood to be required that we work together. And that is a big part of our mission, and certainly a big part of the current law school's mission going forward. So this is an exciting opportunity. We'll have someone who's in his own right outstanding making the introduction. You'll have a great lecture as well, and we will all be better for it. So let me just say thank you for attending. Those of you who are regular supporters of this endeavor or others related, thank you for that support, and I hope you enjoy the rest of the festivities as I get off the stage. Thank you.
All right, thank you, Chancellor. So when I arrived at Maine Law, I heard that Judge Coffin's signature introductions to this event were one of the highlights, if not the highlight, often of the event. To keep the tradition going, the Coffin clerks have stepped up and supported this lecture series with a new series and chapter of introductions from people who knew the judge so well. And we were all set to do that once again this year, and not just with a former Coffin clerk, but with a former Coffin lecturer, Jonathan Lash, who's a former president of Hampshire College and a former president of the World Resource Institute. He was all set to introduce today's speaker, but of course, as has happened so often in recent years, life intervened. Jonathan broke his leg and could not be here today. But we do have a wonderful introducer today for today's lecture, my colleague and friend, Charles Norkey. Charles is the Benjamin Thompson Professor of Law at the law school. He directs the Center for Oceans and Coastal Law, and he's a faculty member of the Climate Change Institute at the University of Maine as well. Charles teaches a broad range of classes from international law to environmental law to oceans law and maritime law and a variety of other topics. Charles has been at the front lines of legal and policy discussions about climate change, the environment, law of the Arctic, and many other aspects of domestic and international law. And Charles has been an active collaborator and partner throughout the years with the University of Maine system, really with other schools throughout the system, and really kind of creating a model for how the law school can work closely together with other institutions throughout the state, and really throughout the world as well. Charles has traveled the world for his work, has connected Maine Law and the state of Maine to partners in Greenland, Iceland, New Zealand, Australia, Afghanistan when I arrived here, Hong Kong, pretty much all over the globe. I'm always very excited and jealous to see where his travels take him next, and always fun to see your photos, Charles. So welcome to the stage.
Picture this. You are pulling a sled. That sled is laden with life-saving provisions against stiff prevailing winds. You are traversing Antarctica. This entails thousands of kilometers of polar crossing. Imagine endurance, as it was penned by Ernest Shackleton. Picture this. You are skiing over snow and ice against stiff winds, attempting to reach Summit Station, the highest point on the Greenland ice sheet. Picture this. You're in Nepal, scaling Mount Everest, overseeing a National Geographic expedition. Your mission is to secure a high-altitude ice core and return it intact to Maine. By the way, you've accomplished this after your 70th year. That picture is our speaker this evening, and whom I know Judge Coffin would have delighted in introducing. Dr. Paul Andrew Mayewski, distinguished professor at the University of Maine, is an acclaimed glaciologist, climate scientist, polar explorer, and director of the Climate Change Institute. He has led more than 60 expeditions to the remotest polar and high elevation reaches of our planet, exploring uncharted areas of Antarctica, achieving first ascents of mountains in the tireless quest for scientific knowledge. His many prestigious awards include the Inaugural Medal of Excellence in Antarctic Research, the Explorers Club Lowell Thomas Medal, the European Union Oeschger Award, and a doctorate honorary causa from Stockholm University, and he is a fellow of numerous learned societies. Dr. Mayewski is the first person to develop and lead prominent multi-interdisciplinary climate research programs at the three poles, has led the International Trans-Antarctic Expedition, and recently, the National Geographic and Rolex Perpetual Planet Mount Everest expedition. He has published more than 500 scientific articles, 2 books, Ice Chronicles and Journey into Climate. He has delivered hundreds of popular and scientific lectures worldwide, regularly appears in national and international media, including the Emmy Award-winning Years of Living Dangerously. And Dr. Mayewski, Paul, generously devotes time to our Arctic Law program in the University of Maine School of Law, be it in the classroom, in research collaboration, and in the field as recently as last summer on our Arctic expedition in Greenland. You are about to hear from a man who revealed abrupt climate change, who continues to illuminate how climate change impacts humans and the wider ecosystem, and who remains devoted to Maine, to our universities, and to our students. Paul?
Thank you so much, Charles. I will get you that dinner later tonight. Thank you. You did a great job. Thank you. Well, I would like to welcome all of you to a presentation that I think is very different for the Coffin Lecture series. I'm a scientist, obviously, not a lawyer, so I'm greatly honored to be able to speak to you. I have a tremendous amount of respect for the things that have been done by law school lawyers in general, including our Chancellor Malloy, who's done so much for the University of Maine system. The highlight for me this evening was to meet the Coffin family and to be able to speak with them and learn more about Judge Coffin and all of his remarkable accomplishments. What I'm going to do today is talk about, as the title says, climate perspectives in a rapidly changing world. I'm going to inject a few adventure stories in there because that's what drives me, that's what drives our students to do the things that we do in remote parts of the world. But first, let me introduce the institute that I direct. We have 135 people in the institute, and we look at the physical, chemical, biological, and social aspects of climate change, which makes us very unique. We look at present climate, which is basically the last 100 years of recorded records. We look at satellite imagery. We also go back in time, hundreds of thousands of years, in fact, a couple of million years, in order to look at how the climate operates under conditions which, as it turns out, until a few years ago, we had never experienced in the last roughly 100 years. We're looking for analogs of past climate that we can learn from to make better predictions for the future. And we are particularly interested in taking all of this information and turning it into a way, along with monitoring current climate and environment, a way in which we can make better predictions for the future. I have a list up here of many things that our institute has been involved in, from acid rain to climate prediction, pollution. I won't read the whole list, but over our 50 years, and we just celebrated, we're about to celebrate our 50th anniversary, making us one of the oldest climate research units in the world, we have been able to contribute and in some cases make dramatic changes in some of these very important environmental issues. The University of Maine research program is dedicated, obviously, to bringing information to Maine and to Maine people. It's impossible to understand what's going on in Maine without understanding what goes on around us. And therefore, we look around the entire world, bring this information back, work within Maine in order to contribute. I'm going to focus today, we do a lot of different things in our institute, but today I'll focus really on climate perspective and climate perspective that's developed by looking at ice. I'm originally a glaciologist, and I'm going to do this by answering a series of questions. I'll go through these fairly quickly. It won't be a very long presentation in that, at least scientifically, but I wanted to just read through them so that when we go to each one, you'll remember. How do we, for example, know that climate is changing? Why is the atmosphere so important? How fast can climate change? Why do we suddenly care about the Arctic? 10 years ago, nobody cared about the Arctic. What are the impacts of climate change? How successful have treaties and legislation been thus far in environmental issues? I know that there are a lot of you in the audience who know a great deal more about legislation and policies than I do, so be kind as I get to that part of the presentation. What can we expect for our future climate? And why should policies and laws regarding climate change evolve more rapidly? So we'll start with the first one. How do we know that the climate is changing? And the answer is that 195 governments have gotten together under the auspices of the United Nations to develop the Intergovernmental Panel on Climate Change. And they have, every 2 to 5 years, released a report. It's the least common denominator understanding. And this involves scientists, policymakers, a very broad range of people. And there is no doubt whatsoever, based on the thousands and thousands of papers that they develop in these reports, that we are experiencing climate change created by human activity and primarily by the rise of greenhouse gases. Other documents come out, for example, related to the Arctic, in which we now realize is an extremely sensitive place and has a great deal to do with the sort of climate that we experience in the Northern Hemisphere. So, what can we do with ice? Ice is a sentinel for climate change. It's the canary in the gold mine. All of these red circles up here show you places in which our institute works. And we do many things in these places, but one of them is to take a look at the changing dimensions, the shape of glaciers. And without a doubt, in every one of these places, there is from significant to some amount of shrinking of glaciers. As these glaciers shrink, they obviously increase sea level. And sea level can and has, in the past, risen tens of meters in a matter of 200 to 300 years. We also look at glaciers and the streams that come off these glaciers to understand water quality in the surrounding areas, because as the glaciers melt, pollutants that we put into the atmosphere that have transferred into these glaciers being deposited are actually impacting humans and the surrounding ecosystem. And we also look at glaciers, particularly in the mountains, as water towers. Water towers because they capture moisture that's available in, for example, the Himalayas of Asia, the Andes, a variety of other places, water that allows people to have irrigation, hydroelectric power, in particular during periods when there is no rain. So glaciers, ice in general, is a remarkable indicator. I like to say that glaciers can't lie. They just simply do whatever they are needed to respond to. In 2018, I was approached by National Geographic and Rolex because of the Everest expedition that I had to lead the expedition that Charles just mentioned. Our goal primarily was to see whether or not the highest parts of the planet were in fact impacted by climate change. In order to do this, our team recovered an ice core from 26,000 feet up. This is in what's called the death zone, where there's so little oxygen that you really can't last much more than 2 or 3 days without coming down. And the most remarkable thing that we learned was, in fact, that the age of the ice, radiocarbon dated from the very surface of the glacier that you're looking at beneath these heavily clothed people, is 2,000, that surface is 2,000 years old. That means that 2,000 years worth of ice has been lost, and as it turns out, it's been lost in the last 3 to 4 decades. So even the very highest parts of the planet are impacted by warming. So, next question. Why is the atmosphere so important? So let me tell you a little story, because this is something that is very dear to me. It was a turning point in my career. I started working, and still have for many years, in the Antarctic, leading over snow traverses, doing a variety of other things. But because I'd been working in Antarctica for so long, I began to think that maybe what I was doing, this is back in the 70s, 80s, maybe what I was doing didn't have anything to do with humans, because obviously the Antarctic, like the Arctic, is far away from people, and therefore could it possibly have an effect? So I started working in the Himalayas, and by our second season in the Himalayas, I realized that I wouldn't be allowed to have any maps. There was no satellite imagery of any place that I wanted to go to. It was still fairly early on, and we couldn't have any form of communication, working in this particular case in India. So I started looking through books from early explorers, and I came across a series of books written by Fanny Bullock Workman, who at the turn of the last century did some of the major climbs in the Himalayas. And there was a picture that you see right now that told me that this might be a good place to go. And that's really all I knew. I knew generally where it was. So we started traveling. Eventually, it would take us 6 weeks from the time that we got to New Delhi in India to make our way into the northwestern part of India in what's called Ladakh. These were the last people that we encountered. They were living on top of their house, and just simply working with them was a remarkable experience. I managed to organize a few of them to help us carry our loads. We carried our share of the loads too, and I somehow assumed that these people would know exactly where I wanted to go. When I tried to explain, I didn't speak their language, where we wanted to go, it was unclear. I pointed in the right direction. They had never actually been any higher than where they lived, which was about 16,000 feet. In fact, why would they? It occurred to me that they obviously have very subsistence environments. They were just worried about where they lived. But eventually, over the next few weeks, we made our way gradually towards this mountain called Nun Kun, which, by the way, I learned later on means mountain. So we then encountered, if you look at the picture in front of you, 3 ice falls. Each one of these ice falls is about 500 feet high. We had to scale these ice falls, make our way to the top, drill our ice core, which was the first ever drilled in the Himalayas, and then make our way back down, bring the samples back. Well, that was our primary task, but something very fortuitous happened. Standing up at 20,000 feet, I saw air masses coming, in this particular case, from the right, from the Indo-Gangetic Plain, and from the left on this picture, but it's actually north and south, the Tibetan Plateau. And the air masses that come from these areas ought to be very different. Tibetan Plateau air ought to be very cold, it should be dry, it should be dusty. Air that comes from India should have a lot of ocean signal in it, agricultural signal, human signal, but nobody had ever really tested this in snow before. We thought this might be a really good way to fingerprint the monsoon, which is the primary atmospheric circulation feature in this area. Turned out, after the snow fell, we went from 20,000 feet down to 10,000 feet, collected a series of samples, came back up to our camp at 20,000 feet, went home, did the analyses, and now this is what is understood. This is a NASA animation of real cloud patterns. In the upper left, you see the clock ticking, except what people have done in this case is taken those clouds and colorized them based on the sort of chemistry they have within them. So in particular, that orange area that you see going across to southeastern United States and into the Amazon contains a tremendous amount of iron, which fertilizes the Amazon. If you take a look at the blue surrounding Antarctica, that's marine sodium chloride. And if you take a look at the white surfaces in the northern hemisphere, that's supposed to depict pollution, things like sulfur and nitrogen, acid rain in the atmosphere. Now, these are real cloud patterns. The colorizing is very simplified. It just shows you a little bit about the chemistry. But this concept that you can fingerprint air masses following about 20 years after we were actually able to show that the snow captures these signals was very important. Why? Because air masses transport cold air, warm air, dry air, wet air, pollutants, and they affect surface currents. So if you know something about the atmosphere and how it has behaved over time, by, for example, an ice core that takes you back in time several years, hundreds of years, you might learn something about how the climate system operates. So the next big event, it's mid-80s now, is trying to see by looking at a highly detailed record how fast the climate can change. And how many people remember The Day After Tomorrow? It came out in 2004. Well, that movie was based on the research that we did in central Greenland. It was a rapid cooling of the northern hemisphere. It was completely covered by ice within a matter of days from a giant storm. Well, that's obviously not what's happened recently. It's quite the opposite. But nevertheless, Hollywood caught on to this long before anybody else did. Despite appearing in magazines, newspapers, doing movies, nobody ever really believed that the climate could operate that fast. So in order to find the right place to drill in Greenland, we did a series of traverses back and forth, up and down, across Greenland. We found the deepest part. We did a variety of other things that are necessary. And I was put in charge of 25 U.S. institutions with a very large National Science Foundation grant. And we spent 5 summers, 5 times 4 months, 20 months on the highest part of Greenland, drilling down in the dome that you can see. We built the dome, we built the station, we drilled down, and we were able, by the time we did the analyses over the next few years, to count back in time, year by year, 110,000 years. Still, this is the longest, most detailed, continuous record of climate change because ice cores preserve not just atmospheric circulation, but they tell you about forest fires, they tell you about volcanoes, a variety of other things. And in that, we discovered that the climate could shift dramatically in less than 5 years, in some cases less than 1 to 2 years, and that this was largely a consequence of shifts in atmospheric circulation and changes in the extent of sea ice, which will become important in a minute. The other thing that we learned was that the timing of these events was coincident, as it turns out, during the period of civilization that we understand now, the last few thousand years. It was coincident with the collapse of Mesopotamia 4,200 years ago, which happened very fast. This is modern-day Syria and Iraq, and there was a drought. They simply built the Mesopotamian capital too close to the desert, and all of a sudden, things changed. It took them a couple of hundred years to build it, and they abandoned it in a very short period of time. This is, of course, the same thing that happened recently and triggered much of the unrest in the Middle East, drought. You go to 900 AD and the collapse of the Mayan Empire, although in Central America, even in Greenland, you can see atmospheric circulation signals that are teleconnected to what happens in South America. The collapse of the Mayan Empire actually happened 2 or 3 different times, very abruptly, strong signal in our ice core. Then if you go to 1000 AD, in the North Atlantic was moderately mild conditions, it's called the medieval warm period. The Vikings went from Iceland to Greenland, colonized, and then in 1400, within 3 to 5 to 10 years, they had disappeared completely because suddenly they were engulfed by sea ice that no longer allowed the annual travel from Iceland to Greenland, which they required for all of their supplies. They never adapted to the local Inuit culture. So what is it today that could potentially trigger an abrupt climate change? Many things in the past have done it, and greenhouse gases have been one of those things, but never in the last 800,000 years, and we have records that go back this far, have greenhouse gases been as high in concentration as they are today, number one, and never in the last 800,000 years have greenhouse gases risen as fast. 100 times faster than any other time in the last 800,000 years. So all of a sudden, you have a potential trigger ready to be pulled on an abrupt climate change event. So after years of people not being interested, including scientists, in the Arctic and the Antarctic, other than for simply the things that go on there, never understanding that there could be a bigger impact. Why are we suddenly so interested in the Arctic? Part of the story is the fact that Arctic sea ice, as of about the early 2000s, began to decline in extent. And this particular image on the left shows you 1980, September, time when the sea ice is not its largest, but certainly quite large, versus 2016. Around 2014 or 15, actually, sorry, 2010, people started to say, it's likely that there will be a massive loss of sea ice in the Arctic Ocean, but it won't happen until 2040. And then a couple of years later, they said it won't happen until 2025, and then it happened almost immediately. So we were certainly not the people to discover this, but we have developed software. This particular one's called Climate Reanalyzer. It's publicly available. We get 2,000 to 3,000 hits a day all over the world. The graphics are beautiful. It allows you to understand what today's weather is. It allows you to take a look at all of the existing recorded records from all over the world. And therefore, much of what I use in the remainder of this talk, the graphics come from this. This is my colleague Sean Burkle, who's also the Maine state climatologist. We can, for example, look at the evolution of global warming. And in this particular slide, you see the time period 1996 to 2013 compared to the previous period, 1979 to 1995. Red is the greatest warming, blue is cooling. First, why would it be cooling? Turns out it has to do with the winds dragging the surface of in this particular case, the Southern Ocean, and pulling cold air up. Why is it so warm in the Arctic? Well, let's focus in the Arctic. The other thing you notice is that we call it global warming, and we are on our way to global warming, but you can see from here, it's not happening evenly throughout the planet. But if we focus on the Arctic, which is the part of the world in which the temperature has risen the most, we find that over a 5-year period, in particular in the Eastern Arctic, the Russian Arctic, temperatures rose on an annual basis in 5 years, 8 degrees Fahrenheit. Now, just imagine what that would do in a place like Maine. In the Arctic, it doubles the length of the summer. And this is a remarkable event. It is exactly the same magnitude, it is the same speed, but not the aerial extent of the major event that occurred 11,600 years ago, which was the transition from the last ice age into our modern day climate. So we experienced not too long ago a very abrupt climate change that, as it turns out, has had significant impacts. It's had significant impacts because it led to a shift in circulation, which I'll explain briefly in a moment, but coupled with this is also sea ice. And what you're looking at is a progression of sea ice in the northern hemisphere and the southern hemisphere, obviously out of phase. It's Earth's most, or certainly one of Earth's most remarkable events. It's remarkable because it changes the surface of the planet, or that particular part of the world, from white to dark. And when it's white, it reflects incoming radiation almost 100% in some cases if it's very white. And if the ice is gone, and in the case of the Arctic, the ice is not that thick. It's only 6 to 10 feet thick. It can be melted in a matter of weeks with the right temperature. Once you melt that, you change the surface to a dark color, which means the heat is all absorbed. And even more importantly, what you do is emit all of that heat that is normally trapped underneath the sea ice. And the net result is that you get 2 to 3 times the temperature rise for every degree of centigrade warming that is experienced anywhere else outside of sea ice covered areas. And when you warm the Arctic, what you end up doing is changing a balance that we have been used to for all of our lives, literally the lives of almost everybody that we can remember. If you take a look, obviously the Arctic is cold relative to the mid-latitudes, and the steeper that temperature gradient, meaning the colder it is in the Arctic, the more likely the jet stream, which is this orange and red thing, the more likely it is to move along lines of latitude, rather straight. However, if you warm the Arctic, what you end up doing is taking that jet stream, the barrier between cold and warm air, weakening it so that cold air can go farther south and warm air can go farther north. And we all know what happens when you take cold air and warm air to put it together. You get storms, you get turbulence, you get instability. Just to give you a dramatic example, in the last few years, not every single day, but a few days in the winter, in midwinter, when the jet stream pattern is extremely irregular, as you can see where that red arrow is going, warm air from the more southerly latitudes makes its way to the North Pole, and in midwinter, in complete darkness, there are days when the North Pole now is above freezing. Absolutely unheard of not too long ago. So what are the impacts of climate change? There are several, and in fact, there are a lot, and I'm sure that if we sat down and talked about them, we would realize that literally everything is impacted by climate change. So what I've done is broken it up into 4 large groups. I'll give a couple of examples. The first of these is health and resource depletion, and I'll just talk about one of these parts. One is pollutants. We've had a lot to do with tracking pollutants over the planet. It started in the mid-'80s when we were funded by Environmental Protection Agency to demonstrate whether or not acid rain was created by human activity, the same as the greenhouse gas story has been until recently. And in fact, that's exactly what we were able to find. That started us to think, if in fact things like nitric acid and sulfuric acid got into the atmosphere as of the Industrial Revolution, then what actually is clean air? What does clean air look like? So to find out the answer to that, we traveled by snowmobile into the interior of Antarctica, and after we got close to the central portion of Antarctica, we got on skis because we didn't want to pollute the area. And then when we had gone about 50 miles farther with skis, we put on clean suits so that wouldn't contaminate the sample. And we sampled the snow, dug down, and assumed that that snow must be the cleanest snow on Earth, and therefore that must be close to the natural level. We never assumed that Antarctica could actually be polluted by human activity. One of the things that we did was about 100 miles outside of South Pole. This is the sort of tent that we've lived in. I've spent close to 5 years living in a tent like this. And we dug a snow pit that was 20 feet deep, and out of that we recovered 500 samples. This took us 4 days. Temperature is minus 50 degrees centigrade, minus 40 Fahrenheit, minus 40 centigrade are the same. And with that, we discovered many different things, but one of the most exciting, as it turns out, was the Chernobyl nuclear accident, which occurred at 51 degrees north. Now we're at the South Pole, opposite end of the Earth, and we found evidence of the Chernobyl nuclear accident. It had gotten high enough in the atmosphere that it traveled. So it's quite remarkable, the things that leave tracers in ice cores. As a consequence of that, I organized 21 countries to begin traversing Antarctica, collecting records of all sorts. It's part of the International Trans-Antarctic Scientific Expedition. We discovered many things in addition to the fact that Antarctica is melting around the edges, but we were also able to show that Chernobyl obviously got to the South Pole, as I mentioned, copper from South America, and uranium from open-pit uranium mining in Australia made its way literally halfway around the southern hemisphere, increasing the levels of uranium in that area by 100 times in 35 years. We've also worked in South America, taking a look at changes in chemistry, water availability. We have sailed in the Southern Ocean now 3,000 or 4,000 miles, visiting small islands that you can only get to by sailboat in order to collect ice cores and to take a look at what sort of pollutants have gotten there. And one of the most recent things that we've done is to work in the Swiss-Italian Alps with a glacier that allowed us to go back in great detail 2,000 years. And from that record, we discovered the following thing. In the upper right, I mentioned that lead has been emitted by human activity for more than 2,000 years. Modern safety levels for lead are based on the levels of lead from prior to the Industrial Revolution. We know that the lead levels were higher than natural because of the Black Death, because during the Black Death, when 50% of the population died right in the area where we were drilling, everything stopped. Metal smelting, use of making coins, literally the levels of lead went down to zero. So what does this tell us? This tells us that we need to be even more conservative in our understanding of what natural levels are and which levels are healthy for us, because lead obviously has an impact on our health. It can cause Alzheimer's disease. It impacts cardiac, respiratory cancers. We've also worked on epidemics such as the Black Death. In addition, we've worked on the 1918 pandemic, showing, based on this record, which goes back several hundred years earlier, that the period 1917 to 1990, near the end of World War I, was particularly wet, particularly cold, and therefore the likelihood of a pandemic spreading was even greater. 50 million people died during that. The net result of everything that we've done all over the world is to show that humans have had an undeniable impact on the chemistry of the atmosphere. We have created an atmosphere that is unparalleled in Earth history. And we have records. I have down here a plot that goes back 5,000 years, but in truth, if I put the full-length plot on here, you'd never see the rise at the end. So we've created acid rain. We've put engineered chemicals, most recently our understanding of PFAS, microplastics, all of these things. Why is this important? 1 in 10 deaths worldwide are a consequence of air pollution. 7 million premature deaths per year because of poor air quality, based on the World Health Organization. So air quality is very important. We have impacted our air quality, and how we deal with this, how we ideally create good policy and legislation, is extremely important. Hence, all of these issues, air pollution, water pollution, climate change, storms, on and on, the thing that we need to do is to be able to apply this information, which requires working with lawyers, which is a large part of the association that has been associated with Charles. So next thing that we can look at that's a major climate impact for what I consider to be the biggest security threat of the 21st century is the economy. There are many different things, but let's just look quickly at this. In the bottom, you see COP27, which is about to start very soon, or maybe it actually has, by the United Nations, largely dedicated to reducing greenhouse gases. In the upper left part, you see the effects of the recent Inflation Reduction Act, with the likelihood that we will have much more solar, much more wind power in the future. It's a fantastic thing. It's a giant step forward, but the net result is it was watered down, sadly, and it will probably get us maybe halfway towards the Paris Climate Accord. No farther than that, and the Paris Climate Accord is already not attainable. Nevertheless, a valiant effort, and we need many, many more of these. The next big thing that is a climate change impact are, of course, catastrophes, and when you have warm oceans and wind patterns that are causing instability, you have an increase in the frequency of storms. We've done a lot of things with this: weather updates, past storm behavior, a variety of things. The other consequence is drought. We all know about California and what's happened there and many other parts of the world. This is a consequence of whether or not air masses with moisture get to these areas. And the answer is that for the Sahara, for California, many other parts of the world, the air mass patterns are shifting, and they're still obviously getting air, but the air, by the time it gets there, has already lost its precipitation. And then, of course, wildfires, which are mostly we think about in the case of the United States, in the western United States. But we live in a state that has a large forest, and we on occasion have drought, which we did for the last year or two. These droughts get worse. The expectation is that we will have more rain in Maine as things get warmer, without a doubt. The Gulf of Maine will be warmer. It'll give us more precipitation. But we do also know that there are times when there are drought. And if climate becomes more extreme, hotter followed by colder, vice versa, we need to be very careful about the way we manage our forests, which we obviously are in Maine, but we need to be very alert to this. And then finally, geopolitics. And if you read down this list, there are tons of geopolitical implications. For example, during the Middle East war, there was something on the order of 30 to 40 refugees as a consequence of that. The expectation for climate refugees is in the order of hundreds of millions of people. Even within our own country, people will be moving around a great deal. And of course, the Arctic is a large part of why we're seeing this. Now, the Arctic has a lot of things that we care about. What's happening to the people, what's happening to the livelihood, what's happening to ecosystems. And Charles and two of his colleagues just recently came out with a paper which lists the various transport pathways across the Arctic Ocean. The one on the far right is the one that goes along the coast near Russia, where the warming is the greatest, therefore least sea ice, greatest likelihood. But as you go into time, 2015 to 2065, as Charles has done with his colleagues, you see that the routes might actually shift, and or there will at least be more routes going right down through the middle, which is the yellow, and then also through northern Canada, which is the red. There are all sorts of consequences politically and legally as we begin to open up an absolutely new ocean and begin to utilize it for resources and shipping. How successful have treaties and legislation been thus far for environmental issues? Well, here's a great example. The Antarctic Treaty started in 1961, now has 54 countries that have basically said this is an international territory. It's not for military use, it's for scientific use, and now for tourism. It's been immensely successful. Part of the reason is it's a really hard place to get to. It's a really hard place to live in, but nevertheless, it was claimed by many countries, not the United States, but by many countries, and they've all put their hold or their claims on hold. Another one that's and wouldn't this be a phenomenal treaty if it could ever occur for the Arctic? It won't, but we need to think about these positive things that can happen from treaties. The Montreal Protocol is another one. It has now had 9 amendments. If you remember, this was in order to save, to rejuvenate ozone, not only in the Antarctic, but also there are ozone holes in the Arctic. And the most recent one is in 2016. Another great success. And it was a success because the chlorofluorocarbons that destroy ozone could be replaced by other things. Makes you think about batteries. We need rare earth elements. Can they be replaced by other things? Because there are only so many rare earth elements out there, and of course, they're not always in places we can get to easily. So, I put together a list of what I consider to be some major climate and environmental surprises caused by humans, and I've listed them here: Arctic sea ice, extreme events. You can see all of them, but the question is, how well have we done with these? They've all been surprises. Nobody ever assumed that these things would happen, but they were all caused by us. The red stars are the ones where we were successful, where legislation could be actually effective. The orange or yellowish stars are places where we tried really hard, did quite a bit, but not as much as we should. The Clean Air Act, I believe the United States was the first country ever to have a Clean Air Act. It was groundbreaking. Europe followed, Asia followed, but the Clean Air Act only accounts for some of the pollutants in the atmosphere. Extremely important, a great model, but it needs to be expanded to include other things. Our institute has been very heavily involved in developing climate action reports for the state of Maine. We were asked by Governor Baldacci in 2009 to create the first report of the state of the climate for a state anywhere in the United States. We've updated this many times, and then under the Mills administration, many members of our institute were involved, in particular in the physical basis for climate part of the Maine Climate Council, which is an amazing forward-looking document. And all of that physical basis basically comes from those reports that we did before. We've also created reports like this for Mali in West Africa, for parts of the North Atlantic, Greenland, Southern Ocean, and Antarctica. So what can we expect from future climate? Future climate, if you take a look at the pinkish part of this graph on the right, future climate is modeled. There is no doubt that it will be warmer, not everywhere at the same time. And of course, if we are fortunate to achieve the Paris Climate Accord, which is highly unlikely, it'll only get to 1.5, perhaps 2 degrees centigrade globally. But take a look at this plot. And then the right part of it, which is very linear, it's got the trend going in the right place. The number that it achieves by 2100 is in question. It will, at least as I said, be 1.5 to 2 degrees. It's based on a grid system that's put over the Earth like this. If you take a look at where Maine, how well Maine is represented in that grid system in global circulation models. There are regional ones, but they're not done for every part of the world, and they're not done as well as they need to be done because it's a long, complicated process. Maine is represented by 4 boxes in the global circulation model. Maine is a much more complicated place than that. If you take from southern Maine to northern Maine, we have a climate that is similar to going from sort of central to southern Europe into northern Scandinavia. We have a very large departure in climate regime. We've developed a program called Climate Futures, in which we're trying to look at this modeling and prediction of future climate more strictly. If you take a look in the upper right-hand side, you see what a climate model output looks like for a particular set of years. Doesn't really matter what they are. And if you look in the lower left, you see what it actually was. Does that mean these climate models are bad? No. They're really complicated to produce. You're trying to absolutely reconstruct how every little molecule in the atmosphere functions. And they point us in the right direction, but we need much, much more detail, and we need to think more outside the box to actually understand where our climate is going in the future. As an example, I'll just give 2. During the Mount Pinatubo volcanic eruption, 1991 to 1993, temperatures throughout much of the northern hemisphere decreased on the order of about 1 to 2 degrees centigrade, resulting in cooling because those particles get into the atmosphere, reflect incoming radiation, resulting in about 1 to 2 years of cooling. In the case of the Arctic, that would be translated because the Arctic has this polar amplification. You would form more sea ice, it would cap off the heat, and it would be equivalent to a 4 degrees centigrade drop in temperature. All of a sudden, all of the Arctic shipping routes done for the winters, at least for those 2 years. So we need to be very careful about how much we depend on trends versus trying to understand what's happening region to region. The big wild card in all of the modeling, in all of anybody's prediction, is really methane. Methane is 30 to 50 times more effective in trapping heat. We know if you look at the bottom that there are a lot of losses of methane from pipelines, most recently the destruction of the Nord Stream pipeline by the Russians. But we at least can go and look at those things. When it comes to the Arctic, which is melting dramatically, so dramatically that that fire that you see is nothing more than these people digging a hole in the snow and dropping a match in. This is methane that's being trapped. If that methane begins to release significantly faster than it is now, we will have a situation potentially in which, as the permafrost melts, as methane is released, in which the temperature estimate for the Arctic, which is right now +5 to +6 degrees centigrade, by 2090 to 2100 could occur much, much faster. It will be an even bigger abrupt climate change than one we've already experienced. So the very last part, why should policies and laws regarding climate change evolve more rapidly? The simple answer comes, from my point of view, in three steps. One, climate is pervasive. Every single thing that we do, literally, is impacted in one way or another by climate change. Two, climate can change much faster than we ever thought, and while the models are very good, we need to keep our eyes open, and we need to understand that it will not change linearly, and that there are potential surprises unless we think more carefully outside the box and use things like plausible scenario planning in order to understand what the possible range of change is. So, I'm really proud to be associated with Charles, the School of Law, because through law, through policy, there are tremendous contributions that can be made, collaborations, and being a scientist is a fantastic privilege, but not seeing the things that are discovered actually turned into application, understood by people, and turned into policy and ideally law is very frustrating. Hence, the reason why scientists and people in the legal profession need to spend more time working together. So, I'll leave you with this. The age of climate decision is here. Our actions will define the course of civilization and the health of our planet. Thank you. Thank you.
So I think we have time for a few questions. Come to the microphones, up the aisles, and all I can call them.
Thank you. If there were one scientific expedition you could do right now, what would it be?
Oh, wow. One right now. There are plenty of, my expertise is primarily in recovering ice cores, and you saw the things we can do with them. So it would have to do with, personally, it would have to do with a place I would go, and there are many glaciers that are disappearing right now. We just came back a few weeks ago from the Andes, the largest tropical glacier in the world, and recovered an ice core down to bedrock about 400 feet from there. And this is a glacier that's disappearing really fast. So that record, it's like a Rosetta Stone that suddenly melts. That would be my personal preference. If there's one thing I could do in science, it would be to try and convince you. Scientists work together, and it's getting better and better. But the data sharing and the thinking is still not where it needs to be. It's rare to be able to get a group of scientists together from different disciplines talking about a common problem. Charles and I took a group of researchers from the University of Maine, University of Southern Maine, to Greenland in 2019, and our goal, and they came from different fields, our goal was to take them to a place that they were interested in seeing. Some had never been there before. And when you get scientists together, not just in a closed room, but in a place where they might actually work together, they begin to solve problems that they've never been able to do before. So having the ability to get more and more people together, and we're actually trying to do that in the University of Maine system. We have a new program called the Climate Challenge Consortium, in which we're trying to find out, we've asked every single faculty member, every single staff member, we've listed a series of things related to climate change, and we want to find out what sort of capacity, capability that we have. We don't want to rediscover the wheel. We don't want to find new software. Charles and I are working on a program also within the system that's called the Interdisciplinary Problem Solving course. Is Pips here? Maybe she didn't make it. Pips Veazey runs the Portland Gateway, and she's been very influential in this. It's an attempt to get lawyers, business people, engineers, scientists, humanists together thinking about important problems like climate change and teaching, in particular right now, graduate students, but eventually undergraduate students, what sort of methodologies are there in these different disciplines, and how can we all come together to do a better job of solving these problems. So that would be my big goal. Thank you for the question. Yes?
Kind of in line with that previous question, I was watching a talk from the Wilson Center from the Arctic Institute, and they were talking about, obviously with the Arctic Council, when it moves to Norway's leadership, that there's a possibility that scientists from the 7 like-minded countries plus Russia can have more informal conversations and collaborations with Russian scientists, because as you spoke about methane, et cetera, in Siberia, do you have any inside information about potential, at least informal collaboration we can do with especially Russian scientists? Thanks.
That's a great question. And obviously what's going on in Ukraine is awful. But it's really remarkable to see how scientists, as long as they're not exchanging secret information, how they can be very effective. I have my last mentor was a French scientist named Claude Lorius, and he was in the Antarctic during the International Geophysical Year. It was a time when scientists all over the world got together to sort of monitor what's going on. It's the reason why we understand now that CO2 has increased, that ozone has decreased. And he was at the French station. It was a tiny little station. He was there for about 18 months. And at the same time, in another station in the Soviet era was a Russian. And the only way they could communicate was by radio. And they're in the middle. At that time, there might have been 200 people in the Antarctic, a place 1.5 times the size of the United States. So they started talking, and they started talking about things that they could do together. And what they ended up doing, even though the two countries were not friendly, was to be able to develop a very large program which has been very significant in climate change. It's told us a lot about how the natural climate system operates. It's a fine line, but it's impossible for any one country, in the case of natural science in particular, but other things too, to necessarily solve all problems. You need, this is why we travel all over the world and get to know the cultures, the people. There's a lot to be learned. So it is really important to keep those channels open. I've worked with the Chinese for many, many years. It's getting harder now to work with the Chinese. I've worked on the north side of Everest with them quite a bit, and they've done some remarkable science. They have monitoring systems out there that they will share with us, but they're not necessarily shared publicly. The bottom line is, if you can get scientists together who are trying to solve a similar problem, they will most likely talk together, and they will most likely go a lot farther in solving that problem. As long, obviously, trying to put aside, if one can, the terrible things that are going on in Ukraine. It's very important to keep doing that. Russia has half of the Arctic. And in fact, they're going to be some of the biggest losers. They have tons and tons of permafrost. And I'd say a good half of Russia, it'll almost be impossible to drive over it. Because as that permafrost melts, once you take a vehicle through once, you've created a long linear lake from the tracks. So, and Russia's not very good environmentally by any means at all. So it's important for them to see what's going on in other parts of the world, just as it was in the Cold War, so that they can go back and try to do the things that inevitably will also be valuable to us. They're going to be one of the biggest methane emitters as a consequence of the melting of their permafrost. Great question. Yes.
Sorry. I was wondering whether or not China, as a big player in working together to reduce pollution, has any legitimate, from an economic standpoint, motivation to reduce the global warming, considering that opening up those passages in the Arctic would give them another avenue for shipping and trade, and if that would play into their decision to work together with the rest of the world regarding climate change?
That's a good question, and the Chinese, they've advanced dramatically. I've been working in China. In fact, I was in Beijing during Tiananmen Square, finishing off our first expedition coming home. And they've advanced dramatically in science. They have polar vessels that now go into the Arctic. They're very interested in the Arctic. They have tremendous instrumentation. And in their way, in one regard, they're still building coal-fired plants. They have a tremendous number of people. They're building more and more cars, so they're obviously a major polluter. On the other hand, they are actually planting forests in a lot of places. So I think, part of them wants to create. It's all because they want to create a better situation for the local people. Now, how friendly a player they are in the Arctic is unclear. They've basically they've done a lot of research. They've collaborated with a lot of people. They would benefit greatly by opening up of the Arctic. And I think that they obviously still attend things like the Arctic Circle. They still have collaborations. Politically, it's probably going to get a lot harder with China. But again, we have to engage everybody in this process. It's a global process. I always think about movies like Independence Day, when the Earth is attacked by aliens. It's the only time everybody gets together. This is almost the same thing, except we're the aliens. We've attacked ourselves, and so we need to work together. It's not really an answer to your question, but thank you.
Yeah, my question is, in working with policymakers who are climate change deniers, what lessons have you learned, or what hopeful ideas can you give us for how you change minds of people who are such deniers?
That's a great question, and there are people now in the fields of sociology who study this, and there are some people who will never change their minds. It's clear. I mean, they're just set in their ways about this. It's unfortunate that it's not a political issue. It's been a politicized issue. I've spent a lot of time speaking with or lecturing in places where there are skeptics, and the couple of important things. A lot of money was thrown into disinformation and climate change by the Heartland Institute, which is operated by the Koch brothers. Tons of money. They actually turned the Google platform around so that for a long time you used to see anti coming up first. But they made a few mistakes in their reports. Their reports have basically no scientific information. They're partial quotes, but they are still hard. It's still hard to change their minds. The one thing that they did do, though, is they kept on harping on temperature, and for years and years, the whole discussion of global warming was based purely on temperature. And if, in fact, the temperature, if you spoke to somebody 15 years ago and you said global temperature is going to increase by 1.5 degrees centigrade, nobody's going to care. If we raised it 1.5 degrees centigrade in this room, we wouldn't even notice it. But they kept harping on that as being the major issue. It's not. It's finally becoming much clearer that there are many, many other things related. And in speaking to skeptics, the one thing that everybody agrees to is that if you consider, as part of climate change, the emission of toxic substances which impact our health, everybody agrees. Everybody wants to have good health and some amount of comfortable living. And that's, I think, one of the ways to engage them. And the other, of course, is to convince them that we have a very old infrastructure in this country. We had the most magnificent infrastructure in the world in the 60s, 70s, and 80s, but it's old. And so do we just repair the existing infrastructure, or we do something completely different? And of course, jobs are always held up as the reason that we should stay the way we are, but now more people are involved in the solar industry than they are in the coal industry, number one. Number two, it's going to be, even if we decided that we wanted to make everything renewable, it'll be 25 years at least before we're able to transition completely out of these things, and probably much longer. So those positions are still needed. And it's a matter of convincing these people that their health is at stake, their quality of life, Migration is a big issue, and as a consequence, we can actually live in a world optimistically that could be a lot cleaner than what we live in now, one that in which we are independent in terms of energy, and one in which there will be new jobs and longer lasting jobs. In the state of Maine, the idea of offshore wind power is unbelievable. It's the equivalent of, I think, close to 8 nuclear power plants. It would create jobs for people in the fishing industry who, the lobstermen may not be in business in 10, 20 years, but they have tremendous skills. It would allow people in the fishing industry to do new things. It would create better jobs. People talk about the Gulf of Maine as being the equivalent, the Saudi Arabia of northeastern United States because of all of the electricity. It's a non-trivial issue putting them in, but when you think about the profits that can be made by considering new entrepreneurial activities. Included in that are some more basic and even more important things. In places like Bangladesh, where seawater is coming in and preventing crops from growing, there are people who've now developed saltwater resistant crops or semi-saltwater resistant crops. So there are tons of new opportunities. I think it's a matter of convincing these people that this is not a losing situation for business, that their health is at stake. And I think the current generation, the young generation, understands this, and I think things will change.
Well, thank you so much.
Thank you.
Amazing. Thank you.